All right, so we are, like I said, we're going to get into Unit 7. I have a little notes packet for you that we'll work on the next 3 days. There's also practice. I don't have a link in Canvas right now, but I have a paper for you. Here's what the calendar looks like. So, I'm speaking. You're not. We're going to do transformations of 3 parent functions, okay? There is like a couple practice problems. I'm probably not going to do all the notes. I will put all the notes on Canvas, but we'll get the gist. Knowing the way these graphs work is going to be important, though, for your future math classes. Also, when we get back from break, we're going to be solving these types of problems, and that will be tested. So kind of understanding how the graphs work does give you a little bit of a pre-teach on that. We'll get back into inverses. We have that split into 2 days, so there should be some time, hopefully not so much today because we just got started and we only have an hour. But the next 2 lessons, we should have some time to review some old stuff for anyone that is retesting. Retest will be Wednesday the 20th, the entire class. You should be able to get 3 or 4 retests done. If you have to take 3 or 4 retests, hold your question, put your hand down. If you have to take more than 4 retests, then you probably are going to need to schedule another time to take some of those. And also, we might need to be having a conversation about your future in Advanced Algebra 2 in 2024 if we're taking 4+ retests, okay? Not if we're just trying to get a 90, 88 to a 90, then you do you. But if we're trying to redo 4 and 5 failing grades, we need to have some combos, okay? So what I'm going to have you do in a second, I'm going to pass back Unit 5 and Unit 6 tests. I made this little sign-up sheet here that if you are retesting, you are going to complete that sign-up sheet. Let's go over it so you understand. You're going to put your name so I know who you are. You're going to put your class. You're going to click whichever retest you choose to take. They're all there with descriptions. You're welcome. Of what everything is. They are in Hack, so you can go to Hack and look at your grades too and see which ones you think you might take. Then you need to understand that if you are retesting a failing grade, you must come in for a tutorial. And if you are retesting, you'll say yes. Or no, I'm not retesting, but I put a little note that it's still suggested that you attend a tutorial if you want to do better. And then you're going to acknowledge that you will be in class on the 20th to take it, or if you will not, it is up to you to reach out to me. If you are not here on the day of the retest and you have not communicated that with me, too bad. So sad. You've got over a week to do that. We've been talking about this date for forever, so it's on you. Time to be a mature young adult. Are we clear? That's what you're going to fill out if you're retesting. Also, if you are retesting, I have test review answer keys with work for every single unit. Unit 4 test review, if you will look, I put the questions on the board. Is this question right there? And the other question on the board was this one. So you can kind of go and see those there. So I haven't posted all the work before, so that's all up there if you are going to go back. But honestly, probably the best thing to do for retest prep 2 is to come in and actually look at your test. Okay? So let me pass those back. We have our new notes packet. Retest. Sign up. Study. Study. Come to tutorials if you need it. When do I have tutorials? Answer. On the chart. It's on the chart. Yeah. Mostly second half of lunch. I also usually get here by 8:30. Did you do the form? Then you should have saw when they were. No, they're during class. During class. Yeah. Okay, so these are our notes. These are about, again, we're looking at a few different functions here, but we're kind of classifying them all as radicals. We will be solving these types of functions second semester, and that is going to be a grade. So we need to know like what the graphs look like. We need to know kind of how they operate, those kinds of things. And that will help us. This little unit is going to help us. But today we need to learn about our new parent functions. that we will study. The first one right here is the square root parent function. So I'm going to be asking you for the names of these. This is what the parent function looks like. You are taking a square root of x, okay? We're going to fill this out quickly, so stay with me. I gave you some x's. We are plugging them into this formula here. Can you take the square root of a negative number, a -1, and get a real number? No, so that is not going to be on the graph. Okay, as you can see, this is what your graph looks like, and it doesn't have a value when x is -1. What about 0? Can you take the square root of 0? It's 0. The square root of 0 is 0. Any root of 0 is 0. Okay? 1, what's the square root of 1? 1. The next input that I picked was 4. Why do you think I picked that? Because it's a perfect square. I would skip anything that's not. So the square root of 4 is? You squared it. That's okay. And then the square root of 9 is 3. Okay? So with these, we kind of want to be strategic in which x values we will use, because we want to take ones that are perfect squares that we can get nice, pretty whole numbers. So you'll see all these points here on the graph, but these are the ones that you'll use. This 0, 0, 1, 1, 4, 2, 3, 9. Does 0, 0, 1, 1, and 4, 2 look familiar?
No. Oh, yes. What's it called?
From the one we just did. What did we just spend like 6 weeks studying? Quadratics. Okay, this is the opposite of quadratics. Your quadratics were what you were doing, squaring. 0, 0, 1, 1, 2, 4, 3, 9, 4, 16. This is the inverse, and that will make sense next class, of a quadratic graph. Okay, it's the opposite. Yes, that is why it's sideways. However, there is only one branch here, and we're going to talk about this not next lesson, but the next, as to why. But this graph does have a restricted domain and range, and it's because we can't take the square root of negative inputs. So, yeah.
Why did you say we're not using -1?
We're not using what anymore?
Oh, -1.
Oh, because you can't take the square root of -1 and get a real number.
I see. Okay.
Yeah. So these do have a restricted domain. So the parent function is restricted to x's greater than or equal to 0, which means we have to use positive numbers and 0. Our range is also y is greater than or equal to 0. This graph does not decrease. It increases on the interval 0 to infinity. So that means starting at that first point. I call this point I'll label it over here. My minimum or maximum, I kind of call it my starting point right there, and we'll talk about that over there. But it increases the whole time. It's a slow increase. It's not very fast like a quadratic, but it is technically, the values are growing. It is positive, the same interval. It is positive from 0 to infinity. Now notice I boxed positive because at 0, oh wait, no, I shouldn't box that. Because I should parentheses that. Because 0 isn't positive or negative. And so the graph is positive from 0 to infinity. End behavior, we'll kind of touch on this. We might talk about this later in the year when we get to logs. But this is saying, like, where's your graph going? So as x goes to positive infinity, as my x's get bigger, where is my y going? Up. To up forever is positive infinity. Now, with this one, because we have a domain restriction, we're not going to be able to do that. So x won't go towards negative infinity. So that's just saying, like, NA, not applicable, no answer. Okay? Symmetry, this is not symmetric about a point or an axis. X and Y intercept are 0, 0. Again, this is just the parent. Now, you will have a minimum or a maximum. I sometimes call this the starting point also, because when I get to a graph, I'm going to show you how that's like where you start to connect those. But the starting point with this function will be 0, 0. And so however that 0, 0 point transforms, that will be our minimum or maximum. In this case, it is a minimum because it's our lowest. but it can be flipped around to where that is a maximum starting point. So that's the square root function, okay? We'll go a little bit quicker through these now that I've kind of reminded you of what this stuff means.
Why is there no symmetry?
There's not like a symmetric point. Like this graph has symmetry.
Okay.
You've got like a point that it moves like this way the same way it moves this way. And you don't have that there.
Only going in one direction.
Correct. Okay? All right, the next one is a cubic function. And that equation is f of x equals x to the third. So you are cubing your inputs. Notice the points change. Okay, we want all these points. Negative 2 to the third power. Negative 2 times negative 2 times negative 2 is negative 8. Negative 1 to the third power is
Is negative
0 to the third power.
0,
1 to the third power.
1,
2 to the third power.
8.
And so you'll see all of these points fit on the graph as well. This is what your cubic parent function. Now it increases fast, way faster. It's pointing more up and down. I will kind of take note of that. It is more up and down. Best thing about cubic and cube root, what's their domain and range? All real numbers. Those are the easy ones. There's no x's that are off limits with x to the third or cubed root of x, because you can take those of negatives. This function is always increasing. So negative infinity to positive infinity. It's never decreasing. So it's always going up. It's positive, again, from 0 to infinity. So it's only positive on this little guy. You could do negative, but it didn't ask us for that. Let's try this in behavior. As x goes to positive infinity, so as we go to the right, where are the y values going fast? Positive infinity. Now, this graph does, because it does have a domain of all real numbers, as x goes to negative infinity, where are the y values going? To negative infinity. Okay? However, the graph is still increasing, though, because you read it left to right. Yeah. Yeah, this is kind of like a weird notation, but this is more like far off. Where's it going? But you always read a graph left to right, and even though they're coming from negative infinity, they're still constantly going up. There is symmetry in this parent function, and it is about the origin. You've got symmetry at 0, 0.
Yes, it is.
There's symmetry.
Oh, it's like flip. It's
It's flipped over the origin.
Oh, yeah.
Odd and even, I'm pretty sure, is that the x-intercept and y-intercept are both 0, 0. And then we also have our inflection point. So you'll see the inflection point is where you kind of have that little like squiggle through it, a little bit of a concavity change right here, that little twist. That's your inflection point. And again, that is the point 0, 0, or however that point changes. And that's what your symmetry is really about in there. Okay? All right, one more parent function.
How is it always increasing?
Because the y values are always going up. You go left to right. So as you're going this way, your y values are always... Because think about it. You start with the smaller. Yeah.
Going to the right.
Correct. And that's how you read increasing, decreasing. Okay.
Not how it was when we did it.
No, it is. You always read a graph left to right. Yeah, least to greatest. Okay. All right. This is the cubed root function. Shh. This is what we're going to be solving next semester. So you're taking the cubed root of these x values. So you're trying to figure out a square root is what times itself gets me something. A cubed root is you're multiplying itself 3 times. Okay? So again, notice we had to be a little bit strategic with our inputs. We only want to take ones that are perfect cubes. So we'll actually go bottom to top with this one. What times itself is 8? 2. Okay? 2 times 2 times 2 is 8. What's the cubed root of 1? Cubed root of 0? Cubed root of negative 1 is, and negative 8 cubed root of negative 8 is negative 2. I will show y'all how to take a cubed root of something on a calculator because it is good to know. Now, this graph, okay, what?
Wait, I thought you can like never have like a negative.
Not with, that's only with square roots or even roots. This is an odd root because you can, because a negative times a negative times a negative will still give you a negative. And that's a conversation that we will talk heavily about next semester, even versus odd. Okay? Good question. All right, this graph is kind of similar to the cubic graph. However, remember I said the cubic is more up and down. This graph has like a squiggle with it as well, but these are more side to side where the cubic is increasing much faster. It's more up and down. This one's more kind of a side to side S, so they are different. They can look similar sometimes, so you got to be careful, especially when you start throwing transformations on them. You really got to look at what the equation looks like, and again, more of that is at side to side or up and down. What's nice about these is your domain and range are both going to be all reals because, again, this is odd. This is an odd root. 3 is an odd number, which means there are numbers that you can take those roots and end up with negatives. Square roots, fourth roots, sixth roots, you can't take negatives on those because those are even. But odds are okay. This graph, as you go left to right, is always increasing as well. So we would say negative infinity to positive infinity. It's a much slower increase than the x to the third is, but it is gradually inching up. Decreasing, it's not ever. It is positive, again, from 0 to infinity. The end behavior is going to be the same. As x goes to positive infinity, y is going to positive infinity just at a slower pace. As x goes to negative infinity, the y's are also going to negative infinity, again, just slower. There is symmetry about the origin, again. Your x and y intercept, again, this is just the parent, is 0, 0. You will have your point of inflection, so kind of where you have the twist, wherever the 0, 0 point is, or however it is transformed. And that's where your symmetry is. So we're going to get through, we're going to fill out these transformations at lightning speed, and then we're going to do one transformation of each in the notes, and then there are going to be some that I skip, and then you have homework. So here's where A, B, C, and D lie in each of our parent functions here. Remember, A's and D's are always happening outside of the function. They're outside of the square root. They're outside of the cubed root. They're outside of the parentheses to the third. So those are always going to be outside transformations. And they're always going to affect which value, your x or your y, if they're outside. Y. They're vertical. So these are going to affect your y's. Not necessarily intercepts, but you will be able to see your, not in these forms, you won't be able to see the y-intercepts. But you are going to be able to see like that inflection point, starting point.
Does horizontal affect the axis then?
Yes. And those have to be on the inside. And then remember, the b value always has to be factored out, which I put that on the little warm-up. So I'm going to choose ones that make you do that in your notes. All right, really quick. A values. If the A value, it's the very front number, those are your vertical stretches or compressions. So if it's greater than 1, it's a vertical stretch by the number itself. If it's between 0 and 1, it's a vertical compression by that factor. If it's negative, that is a reflection over the x-axis, or I think a lot of times y'all like to call it a vertical reflection. The D values, those are at the very end of the equations. Those are your slides, vertical slides. So, and they're normal. So if it's a plus D, then that means your graph is going up. However many, if it's a minus, you're going down. C's on the inside, those are your horizontal slides. Those are opposite though. Inside's always opposite. So if it's X minus C, then you're really moving to the a plus C, you're moving. B's are the tricky ones. They have to be factored out. They're also the reciprocal. So if B is greater than 1, then that's really a horizontal compression by the reciprocal of B. So that would mean you'd have a whole number in there. When you're describing the factor, it would be like 1 over that, which would make you think compression. If it's already a fraction less than 1, when you flip it, it's going to be a number bigger than 1, so that makes you think stretch. And then if it's negative, that reflects the y-axis, or it's a horizontal reflection. And I'm okay if you abbreviate like I am.
That's still by 1 over B.
These are 1 over B. The reflection is just over the axis. And there's no reciprocal at that, because that's just a negative. And the reciprocal of -1 is still -1. Okay? All right, so again, I'm going to choose to do the harder questions with you. I will work out the easier ones and put them on the answer key on Canvas, but we're probably just going to be doing the evens if I were to guess. These are a little bit, yeah, we'll just do these. Okay? All right, so here's what's going to get a little bit tricky is that they're all going to be jumbled with what parent function we have. So the first thing is on number 2, when you look at this equation, what parent function am I talking about? This is the square root. And what's the square root parent equation? Y equals square root x. And what are the square root of x points, parent function points? Only ones that work. Start at 0, 0 with these, because we don't do negatives with those. 0, 0, 1, 1, 4, 2, and 9, 3. I know some of y'all have them memorized vertically, but I'm talking about an ordered pair specifically. That's the parent function points. So let's do this real quick, and then we'll sketch our graph on here. What's wrong with this equation right now?
There's the B.
Your B is not factored out, and if you are taking the retest on Unit 4, Topic 1 that has transformations on it, you are going to have to do this. So I'm going to write it above. Really, I'm dealing with 2 square root. The 2 does not change. The negative needs to be factored out, but it needs to stay inside the radical still. It's still a B value. How is that going to change what comes after? And then the +1 stays outside. So what are my transformations? What does the 2 do? This 2. What is it? No, 2's on the outside. It's a vertical stretch by 2. This is an A, this is a B, this is a C, this is a T. You need to really look at where the placement is, inside or outside. Next, I have a negative on the inside. That's a B. What does a negative B do? Reflect the y-axis, or you can say HR. Either one of those are fine. -3 on the inside, that's a C. That's going to move our graph to the, how many? And then +1 on the outside is going to move us. And then I need a new table. I like to do my y's first because those are easy. So my y's are affected by the outside numbers and there's no change. So 2y plus 1 is what I'm going to do to my y's over here. My x's, now remember the negative, if there's a negative on the inside, that has to go. That does not apply to the opposite roll. Because again, when I say opposite, it's the reciprocal. And the reciprocal of -1 is still -1. So negative x, this has to be the opposite. Plus 3. That's what goes in the table. Now this asks for the domain and range, but I'm also going to talk about this starting point here. And your starting point can be found by your C and D value. It should match what this 0, 0 point is going to change to be, but it's kind of like your vertex of a parabola, where we would find that from there. We flip the x, keep the y. So what's the starting point of this graph going to be? Flip the x, keep the y. Now this should match what I get when I plug into my table, okay? And I want you to kind of call it a starting point. It will be a minimum or maximum, but we need to look at how the graph is going. But this is the point that I'm going to connect from, because these graphs are a little bit weird and people mess them up. So that's why I like to call it a starting point. All right, let's calculate our new y's just real quick. 2 times 0 plus 1 is? 2 times 1 plus 1 is? 2 times 2 plus 1? 2 times 3 plus 1? My x's, -0 plus 3 is, which there's that starting point right here. -1 plus 3 is, -4 plus 3 is, -9 plus 3. So I'm going to put those on my graph. 3, 1. 2, 3, -1, 5. So this is kind of weird. We're going backwards. It's because of that horizontal reflection. -6, 7. But again, I labeled what my starting point was, and that's going to tell me how I connect the graph. I start there, and then I go. So my curve is going to look like this. It's not a very good graph. Like that. So my starting point will actually be a minimum. In this case, it's the lowest point. And again, remember what the parent looked like. If you want to sketch the parent on there, sometimes people think that's helpful. Here's what my parent function looked like in pink. The original graph. So it still kind of has that half parabola, but it's opening the other way because of this horizontal reflection. So how would I describe the domain? The purple graph.
X is
Less than or equal to 3. What about your range?
Y is greater.
Still going up, so you're going to use greater than or equal to, and then that here. So these help you get there and there. Will, what was your question?
I was gonna say, on like this kind of problem, but for the cubic functions,
Mhm.
if it has that kind of flip, would it then be negative since it's going, like it's sloping down like that?
If you flip the cubic function, it could make it decrease.
Okay.
Yes. Depending on how it flips. Okay. So here's another square root for you. I'll work it out on the key, but we're not going to have time to do it right now. All right, flip over. We're going to do 5. I don't know what happened to 3, but it's not there.
So the previous one it was less than equal to 3.
It was less than or equal to for the domain because it was going to the left. Yes. Okay. All right. Let's do number 5. Okay. What parent function is this? And the original equation is x to the third. And I'm going to sketch it. Instead of sketching it on the graph, I'm going to just sketch it right here. So that's what that function looks like. So it's going to be a little bit twisty, but it's going to be more up and down. Cubic parent function points are what? Flip back to your little graphic organizer if you need it. Give me the ordered pairs.
-2, 1, -1, 0, 1, 2.
What's the domain and range of these? You should be able to do all these real quick. And your point of inflection, no, it's cubic,
Oh, cubic.
because it's x to the third.
0, 0, right?
You got a b value there, though, that is not factored out, so you need to fix that. Again, it stays inside the function as a b. Do not put it outside of the to the third. You should got a double parentheses situation. -2, open parentheses, a second one. What's left in there?
X minus
Plus 2.
Oh, X plus 2.
Double parentheses to the third plus 4. Okay? When you're factoring that b value out, it has to stay within the function, within the radical, within the cubed. It doesn't become an a value. You can turn it into an a value, but we're not. We're going to keep it like that. So list your transformations. Some of these are going to go off the graph. Actually, just one will. List your transformations, make your table, we'll sketch your graph, and then we're going to try to get one more done. And again, in pre-cal, they're going to expect you to know the basic shapes of these graphs and these attributes, the domain and range, these points of inflections or these starting points. They expect you to know all of those, these key points. Just a reminder, y'all have to do your table based off of the factored out equation. This happened a lot on the quadratics test. Once you factor it out, that's how you do the describer of the left and right. That's what goes in the table. Some of y'all would factor it out, but then not change it in the table. Like X out the original and do everything based off of this. And again, your point of inflection, that 0, 0 point, should match that C and D value, and it's still going to follow the same rules. You flip the sign of C, you keep the sign of D. So your point of inflection will be -2, 4. And you'll see that you have that little twisty going through that point on your graph. Okay, so you can see that this point of inflection, again, is where you have a little bit of a change in concavity. I know the numbers got kind of big. That can happen with those. Okay, flip over real quick. Number 6 will be the last one, so that way now you know how to do. You have like one of each for your homework. I'll work out the other graphs and put them on Canvas. What parent function is number 6?
Cubic root.
Cube root. And it is, it's just, I don't know, it's just what it is. Okay? So the points you're going to use with the cubed root are going to be the reverse. -8, -2. -1, -1, 0, 0, 1, 1, 8, 2. Okay? You do have to factor out that b value of 3, what that will look like. The negative stays on the outside. 3 stays on the inside. And then it's multiplied by, like that, -2. You don't have to change it because it's a +3. So what is your table going to look like based off of that? What are your y's going to do?
Negative y plus 1.
-y + 1. What are your x's going to do? 1/3 x plus 2. Have fun with that. You can use calculator for that if you need it. Or go to decimals. I always go to decimals. What's your domain and range?
All real number.
All real numbers. And then your point of inflection will be what?
This one. With the 0.
2, 1.
+2, 1. And that's what... Now remember, this function's going to be more side to side with your curve, like that. But you'll get your new points from there. Your homework, I just handed it to you. You have one of each type of graph to do. Bring that with you next time.